गुड इवनिंग फ्रेंड्स, स्टडी विद द पाला इंजीनियरिंग एंड जनरल जियोलॉजी परवीन सिंह। तो हमारा इंजीनियरिंग प्रॉपर्टी ऑफ रॉक चल रहा है जो कि 17 चैप्टर है। और अब हम पढ़ने वाले हैं रॉक्स एज साइट फॉर कंस्ट्रक्शन। ठीक है, साइट पे कैसे कंस्ट्रक्शन और रॉक का। ठीक है, इंट्रोडक्शन से। तो रॉक एज साइट्स फॉर कंस्ट्रक्शन इंट्रोडक्शन। Rock foundations are always sought after in selecting sites for important engineering project. This is because rocks offer a number of advantage compared with the soils in terms of stability and durability. It is known that even the weakest rock may be better in strength and reliability than many good soils. Rocks may form foundations beds for any types of buildings, ranging from a simple residential house to a very complex and multi-storied buildings or a palatial structures or fort. Water and oil tanks and storage buildings, they are invariably the best sites for big engineering projects like dams and tunnels, highway passing through sounds. Rocks offer for less difficulties subsequent to their constructions. For these reasons, a civil engineer must be thoroughly conversant and with the essential properties of rock related to the designs of structure. These includes the usual properties like compressive strength, tensile strength, and shear strength. The deformations characteristics such as modulus of elasticity and permeability of rocks forms other very important qualities to be determined. So a lot of progress has been made during past few years by workers engaged in the field of rock mechanics to diverse reliable methods for testing properties of rock in connections with the selection of sites for engineering project. Presently, more than one technique is available for testing each of these properties, although full standardization is yet to be achieved for all the tests to be carried out for finally establishing the suitabilities of rocks as sites. The following methods could be generally taken as reliable in many situations. These can be supplemented by the experience gained by the engineers and the geologists through their professional careers. The test for selecting rock sites are divided into main categories: laboratory test and institute test. A few of them from each category are mentioned only in outline in the following paragraph. Laboratories testing of rocks. The following properties of rock samples obtained from the proposed sites may be tested in the laboratory: unaxial, compressive tensile and shear strength, modulus of elasticity, Poisson's and ratios, and triaxial strength values. And all of these tests are generally carried out on cylindrical core samples of specified dimensions made from the representative core from different sites. Further, all of these tests can be carried out in the strength of materials laboratory of civil engineering. Unaxial compressive strength, यूनिएक्साइल कंप्रेसिव स्ट्रेंथ कहेंगे. तो दीज टेस्ट आर कैरिड आउट ऑन सिलेंड्रिकल कोन सैंपल्स विद लेंथ डायमीटर रेशियोज 2. So it is possible, however, to use cylinders of slightly different dimensions. The result are then reduced to length diameter ratio of 1 by the relationship C0 to CS and 0.8 to 0.2 L./D. So where CO is the observed compressive strength, L and D are the length and diameter, D diameter or L length of the specimen actually used in the test. The value CS is then regarded as the standard compressive and uniaxial strength. At least 3 test specimens shall be used to get average value. The procedure for determinations and range of compressive strength for common rocks has already been discussed in details under an earlier articles. टेंसाइल स्ट्रेंथ, ये भी एग्जाम में आते क्वेश्चन, इनके डायग्राम बनाने को कैसे, जैसे ये है स्पेसिमेन को दिखाया है, बीच में दबा हुआ, तो उस पर जब हम प्रेशर डाल रहे हैं तो वो कैसे उसका आ रहा है, द डिटर्मिनेशन टेंसाइल स्ट्रेंथ को कैसे मेजर कर रहे हैं, तो इसको है, इसकी भी डेफिनेशन करिएगा अच्छे से लर्न. The tensile strength of rock samples may be determined directly or indirectly. The direct methods would require elaborate means to avoid bending, whilst applying tensile force by gripping the specimen at both the ends. One practice for this purpose involves fixing plates at the end of test specimen using strong epoxy and resins and then applying the grips. It is a very complicated process, and since determinations of tensile strength is seldom required very accurately, a simpler indirect method is commonly applied. The indirect method is called the Brazilian test. ये भी बहुत नाम आता है इसको, ये साइंटिस्ट के नाम पे है, ब्राजीलियन टेस्ट का है. And consist of loading test cylinders diametrically in such a way that the applied loads would develop tensile rupturing along the diametrical planes of the specimen. The loading is increased slowly at a constant rate till the test specimen fractures. The tensile strength is then calculated using the relationship. ये फार्मूला याद कर लीजिएगा, आएगा एग्जाम में, कई बार प्रैक्टिस करिएगा, छोटा सा है. TS is equal to 2P upon pi dl. तो here D and L are the diameter and length. D diameter को indicate करता है, L length को, of the specimen respectively. Shear strength, ये भी important definition है. It is an important property at rock sites and is determined by laboratory as well as a field test. In a laboratory testing, the bar-shaped specimens held with the grips and supported at both the ends below is loaded from above slowly at a constant rate. Rupture occurs as the shear strength of the specimen is exceeded and is indicated by the failures along the two planes. The shear strength S is then obtained by the relationship S is equal to 1 by 2 P upon A. So where P is load at failure and A is area of a cross section of the specimen under load. The direct shear strength test has many limitations. Value obtained are not always strictly reliable. Modulus of elasticity. As with other solid materials, the modulus of elasticity of rocks indicates their property of undergoing deformations when loaded. The deformation is recovered when the load is removed. It is determined in accordance with the Hooke's law that states in elastic substance stress is directly proportional to strain. It is expressed by the relationship stress upon strain is equal to E or modulus of elasticity. It is tested for rocks by loading test specimens, usually cylinders of L by D ratio of 2. Also where L is the length and D is the diameter of the specimens under uniaxial compressions and sometimes under tension. The axial deformation, that is the change in length parallel to stress direction, is in diameter at the application of each increment of load using strains gauge. This process of incremental loadings and recordings of strains is continued till the specimen actually breaks the limits to which it remains elastic. Example, recovers the original shapes when the load is removed, is reached slightly earlier than the breaking load. The stress strains values, when plotted in graphical manners, given lines or curves showing the elastic behaviors of the rocks and the slope of the lines drawn from the point of origin or zero load as a tangent to this curve is called an initial tangent modulus. It is the commonly referred value of a modulus of elasticity of the rocks. Rocks show great variation so far as their elastic constant are concerned. They show all variations ranging from the good as perfectly elastic to practically inelastic. So this depends upon their composition, texture, and structure. Sometimes it is possible to broadly group the rocks into ones of three classes on the basis of modulus of elasticity. Quasi-elastic rocks in which the stress strains relationship is expressed by almost a straight lines till the point of failure. Such rocks include massive, densely packed and uniformly structured varieties of igneous, sedimentary, and metamorphic groups such as syenites, diorites, dolerites, gabbros, basalt, and quartzites. Microgranites also fall in this category. Quasi-elastic rocks have so E values ranging between 6 multiply 10 to the power 5 to 11 multiply 10 to the power 5 kilogram per centimeter square. So semi elastic rock are coarse grained, slightly is open packed, slightly is porous, and with very minor, if any structural discontinuities. The semi elastic rocks are arbitrarily assigned E values and ranging between 4 into 10 to the power 5 to 6 into 10 to the 5 kilogram per centimeter square. Coarse grained igneous rock like granite, some massive compact sediments like sandstone and dolomites may often show semi-elastic properties. In these groups, the curve indicating the modulus of elasticity is such that its slopes tend to decrease with increasing load. B in figure 17.8. Non-elastic rocks are those in which stress-strain relationships tend to break in two zones: an initial zones of steep slope followed by a curve of least slope. These are open textured coarse-grained rock rich in structural discontinuities, and E values obtained with such rock are generally of the order of less than 4 multiply 10 to the power 5 kilogram per centimeter square. स्ट्रेन एंड स्ट्रेस, तो ए बी ये ए और ई है दिया हुआ, ए बी सी और स्ट्रेन है और स्ट्रेस स्ट्रेन रिलेशनशिप इन डिफरेंट रॉक, ये बना दीजिएगा करो। ठीक है, थैंक यू, प्लीज गिव अ पॉजिटिव रिस्पॉन्स।